Hello everyone, and aren't you excited to be in this lesson today? It is optimization problem type 3, the final optimization lesson in this channel. And in that spirit, it is also the most advanced problem. So after I read you the question here and clarify any misconceptions, I encourage you to pause the video and try it for yourself, because I assure you, if you can internalize this process and really understand it, then you will know that you understand and comprehend the heart of optimization. So here's the question. Determine the slope of the line such that the area bounded by the xy axes and the line is minimized, given that the line passes with a point 1, 2, there it is. Okay, so what is the question even asking? Okay, so we have this line with a particular slope n, and the area bounded by the x, y axes, and the line. Oh my goodness, now I get it. It's that triangle. Okay. So, how does the slope even relate to the area? Well, think with me here. Let's say the slope was like that. The area would be this, bounded by the xy axis and the line. That's if the slope was steeper. Well, what if the slope was flatter? It would be something like that. And the area is simply that. And it's not the same as the given one. Now, we're asked to find the slope m such that the area is maximized. Oh, my m disappeared. There it is. Okay. So, now is where I recommend that you pause the video and try it for yourself. It is a bit of a thinker, so don't get discouraged if you don't get it. We are going to review in 5, 4, 3, 2, and 1. Alright. First, I want to discuss the domain. Now, when I say the domain, which variable am I referring to? Is it the x, the y, the b, y-intercept, or the m? There's 4 choices, but I think you can appreciate why I would choose m. It's because that's the slope, and that's the value that we're actually trying to find, and we need the realm of where it can exist. Where can it exist? Okay, so I ask you to keep thinking with me. Let's conjecture that m is a part of all reals. Let's test that. Let's see if m can be in the positive realm. This is a positive line because it has a positive slope. Does it work? Does it satisfy the context of the question? Well, no, because the area is unbounded. So m cannot be in the positive realm. Well, the only thing separating the negative realm and the positive realm is the intermediate 0. So can it be a horizontal line such that m equals 0? And the answer is once again no, because the x-axis would go to infinity. So I hope you can appreciate why the domain must be from negative infinity to 0. Another way to write this is m is an element that fancy E represents element of the set of all real numbers such that they are negative. And no, that is not some weird trident shape R. That is just the R with a double stroke. There it is. And the negative exponent simply means you want the negative reals. So now that we established our feasible domain, we can move towards finding the equations and overall the area function that we want to optimize. Okay. So what is the shape bounded by the 2 axes on the line? Well, okay, here's my axes. Here's my line. Oh my goodness. It's a triangle. Okay. What is the area of a triangle? Well, don't think too hard now. It's just 1/2 length times width. If we call this the length and that the width, there's no problem. Okay, we got that. But how do we actually turn this into a slope-related equation? Well, think back to your fond middle school days, where you simply learned that the slope of a line is just y equals mx plus b. Here we're getting something with the slope. Now we're getting where we want. Okay, using the given point, this particular line we know passes 1, 2. So now we can get an equation solely in terms of m and b, using the coordinate that y equals mx plus b, y1, this line, passes through. So substituting 2 for y and 1 for x, we get 2 is equal to m times 1 plus b. b plus m equals 2. That's our constraint. And you'll see that come into play later. Okay, but you might be like, what? That only introduced 2 more variables. We have L, W, B, and M. How do we navigate between these? Well, I ask you to observe with me here. There's the origin, there's the y-intercept, and there's the x-intercept. I'll label this xi, and we know the y-intercept already has a name, b. So that's b. Well, I hope you can see that length is just the same as xi, and width is the same as b. Okay, I can see how this relates to this, but how does this relate? Now let's investigate that further. Xi is when y equals 0. It's the x-intercept. And why is it y equals 0? Well, that's because it has no height. In other words, the x-axis is a fancy name that we give to the line y equals 0 because it constitutes the xy plane. Okay, so x equals 0, and we know that y equals mx plus b. So 0 equals mxi plus b. Isolating, don't think too hard now, it's just xi equals negative b because we subtracted on that side, and then divided by m. So it's negative b over m. And oh my goodness, what have we just done? We know that length equals xi, and xi equals negative b over m. Therefore, length equals negative b over m. And we have a equation for our area of a triangle. It was just 1/2 length times width. The length is this, and width is that. So it's equal to 1/2 negative, oops, I should put parentheses, negative b over m, right here, and then b right here. So therefore, oopsies, sorry about that. So therefore, the area is simply equal to negative b squared over 1/2 m. I can write that as 2m. Oh my goodness, okay, we're almost there. Now we got area in terms of 2 variables. Do you remember this? That's our constraint, and as I've said earlier, it will come into play. If you don't remember, it's b plus m equals 2. Well, now we can get a of m or a of b. I prefer a of m because it solves the question faster. Because we are ultimately trying to find the slope that minimizes the area of the triangle, Okay. So isolating for b, we get is equal to 2 minus m. So therefore a triangle is equal to negative b squared over 2m. Okay, we have to do some binomial expansion. B squared is equal to 2 minus m squared is equal to, okay, I hope you know the formula, or just the general rule. It's just 2 squared minus 2ab plus b squared. There we go. So therefore, a of m is equal to negative 4 minus 4m plus m squared over 2m. Simplifying, I will divide each of these numerators, each of these terms in the numerators, by the denominator so I can avoid the ever grueling quotient rule. So doing that, we have a of m is equal to negative 4 over 2m plus 4m over 2m minus m squared over 2m. That's just equal to minus 2m to the negative 1 plus 2 minus m over 2. Now we can get simply a prime of m, and the reason is because we want a prime, the derivative function, to equal 0 such that we can find a min or a max. And in this case, since the question gave it to us, we know it's going to be a minimum. So how do you differentiate this? Well, okay, we do some chain rule here. So bringing that to the front, you get positive 2. M to the minus 1 is minus 2. That's fun to say. And then this goes to 0. And this is negative 1/2. There we go. And we want this to equal 0. Okay, let's see what we just did. So we get 2m to the minus 2 is equal to positive 1/2. Divide by 2 on both sides, you get m to the negative 2 is equal to 1 over 4. What does this mean? It means 1 over m squared is equal to 1 over 4, which means m squared is equal to 4. Therefore, m is equal to plus, I shouldn't write that, not plus minus, but simply the square root of 4. And what realm is it? Remember, we established this for a reason, the negative realm. Therefore, m is equal to negative 2. M is equal to negative 2. Therefore, we've got the slope. Okay. Find the slope such that the area bounded by the x and y axes of the line is minimized. In this case, we don't need to test the endpoints because we know that the domain, when it's negative infinity, it's not going to be bounded at all when the slope is negative infinity. And the same case is when it's 0. So if we continue our CP's test, critical points test, m equals negative 2 is like the only participant and subsequently the only winner. So we did it. The slope, apologies for the sloppy handwriting, but I think you can appreciate that we've already solved the question. And I think it's beneficial for every student to write a couple of words, sort of just like explaining what they did to show the instructor that they know what they've did. So the slope is negative 2, which it doesn't maximize, which minimizes the area. And depending on the variations of this question, they might actually find you what is the minimal area. We could do that for funsies. So we know that it's going to be a of negative 2. I forgot my a. It's going to be I forgot my a function. Let's look here. It's going to be this. So let's see. Let's eyeball negative 2, huh? So it's going to be minus 4. What's over minus 4 again? So it's going to be plus 1, and then it's going to be minus 1 right here. Oh wait, no, apologies. It's going to be 4 times negative 2. This is going to be positive 2. So we got 1 plus 2 right now. So 1 plus 2, and then over here we have m squared, which is just 4 over 2m. It's just 4. Minus 4 actually, and we're minusing this, so we're adding. another 1. So their area becomes 4. It's equal to 1 plus 2 plus 1 is equal to 4. Ladies and gentlemen, I hope you enjoyed this video.